Okay, students, so we're back and with some proofs formatted a little differently, but I wanted to do it like that just to deepen your understanding and make sure you do the best you can on the test. So notice how instead of writing like if two angles are supplementary then they add up to 180 degrees, this is really just the definition of supplementary. Furthermore, same with this one right here. All right, and I'm going to elaborate as we progress, but just let's look at this. All right, so given A is parallel to B, so let's just focus on this proof and we'll talk about the reasons as we need it. All right, we need to say that 5 and 8 are supplementary. All right, so let's just start this proof. Let's dive in. 5 is congruent to 4. Why? Well, what's the relationship with them? Well, these are alternate exterior angles. So, well, remember, if two lines are parallel and intersected by a transversal, then alternate exterior angles are congruent. So this is just another way of reminding us A, E, A. Theorem, just actually writing out the theorem. So we'll write D, because that's D right there, and we'll shorthand it as the AEA theorem. But guys, I want you to realize what the theorems are saying, what the definitions are saying, so on and so forth. All right, that's a little practice. All right, now the measure of angle 5 equals the measure of angle 4. So remember, angles, if the shapes are the same, their measures are equal by the definition of congruent angles. And we would say that anyways. I'm just going to write E there. All right, we say definition of congruence. Sometimes we even say definition of congruent angles. Okay, now 4 is supplementary to 8. All right, how do we know 4 and 8 are supplementary? Well, it looks like they're forming a linear pair. All right, and we actually have it right here. Usually we just say the linear pair postulate. But what does the linear pair postulate actually say? It says if two angles form a linear pair, then they are supplementary. And that's the linear pair postulate. So we're just writing down what this stuff actually means. Okay. Now it says that they're supplementary. So then this is when it comes into play what I was kind of talking about at the beginning. Remember, supplementary can be written as a biconditional. So we said that they're supplementary. So now they're going to add up to 180, because if two angles are supplementary, then they add up to 180 degrees. So this just kind of emphasizes the flow of the proof and how it all relates together. Def of sup. All right. Furthermore, look how 5 and 4 equal each other. So I can replace 4 with 5 just by our good old substitution property. I'm not even going to write it out because we say substitution all the time. And then see, this is interesting. It's not too bad to organize a proof a little differently like this. Why? Because now we can say if two angles add up to 180, then they are supplementary. Well, they add up to 180, so they must be supplementary by C, which again is still definition of supplementary. Supplementary is a strong definition. It can be written as a biconditional. Angles are supplementary if and only if they add up to 180 degrees. And that's the proof. All right, that's it right there. Oh, and here's a round of applause. Thank you. I'm actually live teaching this right now and everyone's clapping for me. Thank you. Thank you, thank you, thank you. All right, well, we gotta stop that, all right? And then let's just do another proof and we'll save all this equation junk for the last video, all right? So, given that lines are perpendicular and the measure of angle 5 equals the measure of angle 4, all right? So that's given to us. So, perpendicular, 5, 4, all right? So, actually, since the lines are perpendicular, we know angle 4 is a right angle. Well, usually we say definition of right angle, or excuse me, definition of perpendicular lines. But we have to specifically say it like this now. Perpendicular lines form right angles, all right? These lines are perpendicular, so this must be a right angle, E. E, and we usually just say definition of perpendicular lines. But that's the actual definition right there. All right, now again, let's look at this. Measure of angle 4 equals 90 degrees. Which one would this be? Well, if an angle is right, then its measures 90 degrees, all right? It's a right angle, so it's 90 degrees by C. We usually just say definition of right angle. And a lot of these definitions can be written as biconditionals. Definition of perpendicular lines, definition of right angles, they can be written as if and only if statements. They're really good definitions. All right, then that was given to us. Measure of angle 5 equals measure of angle 4. All right. Now, 4 equals 90 degrees. So I can substitute in 5 for 4 and create this one. This one's just substitution of equality. F. Let me even put F there, because I want you guys to put these letters there. All right, if angle 5 is a right angle, or angle 5 is a right angle, so then this one is if an angle measures 90 degrees, then it is a right angle. So 90 degrees, so we can say it's a right angle by B. And again, we usually just say definition of a right angle. And remember, we can say an angle is right if and only if it's 90 degrees. So then, notice how we said, well, 5 is a right angle. So these lines are perpendicular because two lines intersect to form a right angle. So 5 up here, these two lines intersected to make 5 a right angle, so they must be perpendicular, A. And usually that's just what we say of definition of perpendicular lines. And then parallel, X and Y are parallel. Well, obviously it's D, because if two perpendicular lines are the same line, then they are perpendicular to each other. Then I don't feel like writing that out, so I'll just put an arrow there. All right. Oh, and then more round of applause because I finished the proof. Yay! All right. We'll do the line stuff in the next video.